This lesson helps you understand what is a logarithm. For the exponential function y equals 2 to the x, the input to the function is an exponent. The output is the number 2 to the power of x. For example, if you input the exponent 3, the output is 2 to the power of 3, or 8. You input an exponent and output a number. For the inverse, you input a number and output an exponent. For example, if you input the number 8, the output is the exponent 3. The output is the exponent 3, to which you raise the base 2 to get the number 8. Writing the inverse as x equal 2 to the y is not very convenient. You need a function in y equals format. Since there is no way to express this, a new notation is used, the logarithm. So instead of x equal 2 to the y, you have y equals log base 2 of x. For example, instead of 8 equals 2 to the 3, you have 3 equals log base 2 of 8. Or the logarithm 3 is the power to which you raise the base 2 to get the number 8. In general, then, the logarithm y is the power to which you raise the base b to get the number x. Or, for example, 3 is the logarithm base 2 of the number 8, because 2 to the power of 3 is equal to 8. Remember, the log is the exponent. Okay, so log base 2 of 8 is equal to 3 because 2 to the power of 3 equals 8. This is a little hard to wrap your mind around since it is so new. More examples will help you understand it better. For log base 3 of 9, set the log equal to x. Then write the exponential form 3 to the x equal 9. And ask yourself, 3 to what power is equal to 9? You can see that 9 equals 3 to the power of 2, and the exponent, or log, is equal to 2. So the answer is log base 3 of 9 is equal to 2 because 3 to the power of 2 is equal to 9. Writing a because statement helps you avoid making mistakes, since it makes you think about the meaning of the answer. For log base 5 of 5, set the log equal to x. Then write the exponential form 5 to the x equal 5, and ask yourself, 5 to what power is equal to 5? You can see that 5 equals 5 to the 1, and the exponent, or log, is equal to 1. So the answer is log base 5 of 5 is equal to 1 because 5 to the 1 equals 5. Remember to write a because statement. For log of 100, set the log equal to x. Remember, when there is no base, the base is 10. So log of 100 is log base 10 of 100. Then write the exponential form 10 to the x equals 100. And ask yourself, 10 to what power is equal to 100? You can see that 100 equals 10 squared, and the exponent, or log, is equal to 2. So the answer is log of 100 is equal to 2, because 10 to the power of 2 is equal to 100. Remember to include the because statement to avoid making simple mistakes. Also, when no base is shown, the base is assumed to be 10, and the log is called the common log. For log base 4 of 1, set the log equal to x, and write the exponential form 4 to the x equal 1. Then ask yourself, how do you raise 4 to a power and get 1? You have to remember about zero exponents. 4 to the 0 equals 1, and the exponent, or log, is equal to 0. So the answer is log base 4 of 1 is equal to 0, because 4 to the 0 is equal to 1. For a tricky one like this, be sure to write the because statement. Here are two more questions that rely on your understanding of exponents. Negative exponents lead to fractions, and rational exponents are roots. For log base 7 of 1 over 7, set the log equal to x, and write the exponential form 7 to the x equal 1 over 7. Then ask yourself, how do you raise 7 to a power and get 1 over 7? You have to remember about negative exponents. 7 to the negative 1 is equal to 1 over 7, and the exponent, or log, is equal to negative 1. So the answer is log base 7 of 1 over 7 is equal to negative 1, because 7 to the negative 1 power is equal to 1 over 7. Again, for a tricky one like this, write the because statement. For log base 3 of radical 3, set the log equal to x, and write the exponential form 3 to the x equals radical 3. Then ask yourself, how do you raise 3 to a power and get radical 3? You have to remember about rational exponents. 3 to the 1/2 is equal to radical 3, and the exponent, or log, is equal to 1/2. So the answer is log base 3 of radical 3 is 1/2, because 3 to the power of 1/2 is equal to radical 3. Remember to write the because statement. Finally, two more questions that test your real understanding of logarithms. The log of 0 is not defined, and the log of a negative number is not defined. For log base 2 of 0, set the log equal to x. When you write the exponential form, you can see this is not possible. You can't raise a number to any power and get 0. And don't get this mixed up with the 0 exponent. 2 to the 0 is equal to 1. So the log of 0 is not defined. For log base 2 of negative 4, set the log equal to x. When you write the exponential form, you can see this is not possible. You can't raise 2 to any power and get negative 4. So the log of negative 4 is not defined. In the next lesson, you'll learn how to simplify expressions that contain logarithms. This lesson has been brought to you by the Math Department of Moreau Catholic High School, a Holy Cross school, bringing hope, building respect, being family, educating hearts and minds.